All right, guys. So we are on the last chapter. So the last thing for this unit is going to be something called the determinant. Okay, and the determinant has many applications in math and science and engineering, but we'll just say we'll just learn math now. Okay. So to do a determinant for a matrix, get this going first. To do a determinant for a matrix, there are two methods. So today I'll show you the first method. Right, so chapter 7.7, and we're going to determine the matrix. We're going to be finding the determinant of a square matrix. So it's got to be a square, or else you can't find a determinant. All right, first thing first, we'll start with a smaller one, and we'll only go up to a 3 by 3, yeah, because any bigger than that, and it gets pretty crazy. So we'll start with the determinant of a 2 by 2 matrix. Right, so let's just say we have a matrix, a square matrix A, and it is, we'll call it A1 and B1, and A2 and B2 for the different entries. Okay, so the determinant, okay, we're going to use DET with the A, or you can also put a little kind of like an absolute value bar around the A for this represents a couple different things. Obviously represents absolute value. In this case, A is a matrix, so that absolute value around the A represents the determinant. And then in the higher level math, you can also call that the order of matrix A. Okay? So to find the determinant of matrix A, right? So you can also put the absolute value bars around the actual matrix. And if you do that, then basically you don't actually even need to have any of this other writing. So like all this, you don't even have to write. If you just know what the matrix looks like and just do the determinant of that, then it can just be, absolute value bar around A1, B1, and A2 and B2. So, okay, so moving right along. So the determinant of matrix A is equal to all of these, but the actual work, or the actual determinant, is equal to A1 times B2. So I like to do this with I like to start out, and this is always going to be the case. So the downwards diagonal multiplied together, and then times it by the upwards diagonal multiplied together, and then you subtract those. So A1, B2, so you get the stuff in red, subtract the stuff in blue, right? And this method's called using the cofactors, the major and minor cofactor, but we'll just say this is going to be method 1, right? So using the down diagonal minus the up diagonal. Okay, so let's do a practice with a 2 by 2 square matrix, right? So so again, if you want to, you can say, this is the determinant of matrix A. Okay, so you can write it like that. Okay, determinant matrix A. So first we're going to do the down diagonal. So we're going to be using 3 times negative 5. So that's going to be 3 times negative 5. And we're going to subtract. And then we're going to be doing 2 times 4. And if it's negative, then you just multiply the negatives as well, like how this one is. Okay, so you're going to work it out. 3 times negative 5 is negative 15. Minus, and 2 times 4 is 8. So your determinant of matrix A is negative 15 minus 3, or your final answer is negative 23. Okay, so determinant of matrix A is negative 23. Okay, pretty simple, straightforward. Okay, you'll have a couple of practice with a 2 by 2 square matrix, and then you'll be doing this process. Okay, so if you are having a little trouble, or if it now went a little fast, go ahead and rewind this video and start it up again. Right, so we're going to do the next phase, which is a determinant of a 3 by 3 matrix, and this one's a tough one. Right, so determinant of matrix B. So again, I can write it as determinant of matrix B, right? Or just for simplicity's sake, I can write down absolute value of B, which means determinant of matrix B. Okay, so this is another way to write it. Keep it a little more simple. All right, so this one's a little tougher. Okay, so this one's going to be, so remember how we did that? The determinant of a 2 by 2, it's going to be utilizing the same procedure. So what we're going to do is we can take any row we want, and we're going to go, I usually use the top row because it makes it easier. So we're going to go A1, and then we're going to multiply this. And then since we're using A1 as a coefficient, we're going to take out everything in the row and everything in the column as A1. And then we're just going to be doing the same thing as a, you see the 2 by 2 matrix right here? We're going to utilize that using the determinant, the first method, right? And you don't know what the second method looks like yet, but we'll call this the first method. So this is going to be B2 times C3 and then this is going to be subtracting the up diagonal, which is B3 times C2. Okay, and that is the first piece. Okay, and then the next piece, we're going to go ahead and do a subtraction. So I kind of forgot to mention this, but this is as good of a time as any other. So if we go in this order, then we will utilize this as a positive, negative, and positive. So if we use the top row, it's going to go in that order. Okay, so if that's a positive number, then it stays positive. If it's a negative, then it's a positive negative, which is still negative. We have to utilize the second row, then it's going to be negative, positive, negative, and it switches. So if you notice, it goes plus, minus, plus, and then minus, plus, minus. Okay, so what do you guys think the third row should be? Okay, go ahead and pause and think about it, or if you're ready. Okay, so the third row is going to be positive, negative, positive again. So again, we are utilizing the first row, so we're using the positive, negative, positive. That's why this next term is going to be a negative, where we're going to write down minus. Okay, so since we're using the coefficient of B1, I'm going to go ahead and take out everything in the same row as B1 and everything in the same column as B1. So all of these are gone. We're going to utilize the same procedure as the first one. So B1 times, okay, and then it's still going to be minus once you get a 2 in order, but it's going to go A2 times C3. Right, so you can write down A2 times C3 minus, because it's always minus, right, for the 2 by 2. And then it's going to be the up diagonals, A3 times C2. So A3, C2. Right, so we're done with that. And then now we're going to utilize the last entry in the row, which is the C1. So again, so C1, and C1 is where it went plus, minus, plus. So C1 would be plus C1, and then we're going to multiply by the entries in the 2 by 2 matrix. Right, so again, anything in the same row, we're going to take out, and the same column, we're going to take out. And that'll leave us with a 2 by 2 matrix. So we're going to start with the down diagonal, so A2, B3. So we're going to go A2 times B3. Again, it's always a minus when you're doing the 2 by 2. And then it's going to be A3 and B2. So A3 times B2. And once you get all this, you work it all out with the subtraction, adding, multiplication, and you will get a number, and that will be your number for the determinant. Okay, so let's go ahead and put that into play. Okay, so you need to watch this section again. Go ahead and rewind and start up again. Okay, so let's go and do a practice run. Oh, that's homework for tonight, but let's do a practice run first. Do I have an example? Oh, yes, I do. Okay, so if we want to find out the determinant of matrix A, so again, I'm going to go ahead and write this, in a different way from what I wrote because I'm going to, I like to write DT, so that way anybody who doesn't know anything about math can actually sort of figure out that this means determinant of matrix A equals. Okay, so I'm going to go ahead and use the first row because I just went over that and it's just the easiest for me. So that's going to be a positive. So we have a positive and then -2. So we're going to be using -2. Okay, -2. Okay, and again, we're going to take out everything in the row as that number and everything in the column as that entry or number. And then we're going to do a multiplication of the 2 by 2 matrix, or the determinant of a 2 by 2 matrix. So we're going to go down diagonal first. So 6, or -6 times -6, okay, that's 36. So I'm going to do all this in my head. Okay. And that's always going to be minus. We're going to go 7 times 0. That's going to give you 0. Okay, and that's the first entry. Okay, oops, didn't want that. Let's see. We'll do a little manual deletion here, guys. So reload every time. Okay, so remember, this first one was a plus, so the 9 is going to be a minus. So it's going to be -9. And then if the 9 was already a negative, then you would go minus a -9, which means it's going to be a positive. But since the 9 is positive, then it's just -9. Okay, so we're going to use the 9. And again, we're going to take out everything in the row as the 9 entry, and we're going to take out everything in the column as the 9 entry. We're going to do a 2 by 2 determinant. So 7 times -6. So that's going to be how I start off my -9. So 7 times -6 is going to give me -42. And again, it's going to be always minus. Then go 6 times 0. Okay, and that's going to give me 0. And that wraps up my second part of my determinant. Okay. Again, I'm going to go ahead and do all these awesome stuff. Okay, and then I'm going to go and do the last entry. Okay, so remember it was plus here, minus, and then the 4 should be a plus. So it's a plus, now whatever that 4 is. So it's just 4. And again, we're going to take out everything in the row as that 4 entry and everything in the column as the 4 entry. I'm going to go ahead and do the 2 by 2 because you can even see that there's a 2 by 2 matrix inside here now. I'm going to go ahead and do that one. Okay, so it's going to be 7 times 7 is 49. And again, it's always minus. And this one's a good example. And then you got 6 times -6. And see how that comes out to be -36? Well, you're not going to disregard that. You're also going to use -36 because it just is -36. Okay, and those of you guys that are pretty good will know that this actually means positive. All right. So go ahead and do this. So it'll be -2 times 36 minus 9 times -42 plus 4, oops, plus 4 times 49 minus 30, sorry, plus 36. Okay, so whatever you get that out to be, you can go ahead and use your calculator if you need to. All right, so I'm going to go ahead and do a little bit of work here. So 2 times 36, that gives me 72, and that's going to be -72. Okay. And I know that -9 and -42 is going to give me a positive, so I'm going to go ahead and put down the positive first. So all I have to do is just go 9 times 42. That gives me 378. All right, and then in the back, I know that if I add these, the 49 and 36, I'll get positive. And if I times it by another positive, I'll get a positive. So the whole thing in the back is going to be positive. Okay, so first, I'm going to go ahead and do 49 times, sorry, mistakes, 49 plus 36. That's going to equal 85 on the inside, and I'm going to times it by 4. That's going to give me 340. So plus 340. Right, and then my final answer is going to be negative 72. So go ahead and use your calculator again, or unless you do this in your head. So you got 70. So you got negative 72 and 378. So that's actually like 378 minus 72. Okay, and then you get 306, and then I'm going to add 340. So plus 340. That's going to give me 646. Okay, I know it's a big number, but that's just the way the cookie crumbles, and that's just the way it works out. So the determinant of matrix A comes out to be 646. Again, that was not fast, but if you need any review, go back and review that, rewind the video.